My name is Alec Hansen, and we will be doing transcription for mRNA. So you have your piece of DNA, you have the 3' side, the 5' side, 3' side, and the 5' side. They are anti-parallel to each other. So to begin mRNA transcription, there will be the TATA box, the TATA, and the helicase will start at the 3' side and go to the 5' side, separating the two strands. You have the sense strand, which will be a template for mRNA, and you have the antisense strand, which is pretty much useless at this point. So now that we have our sense strand, you have RNA polymerase, which will add nucleotides that are complementary to the sense strand, making premature mRNA. Instead of a T that would be complementary to A, they use a U, and that's it. Now that we have our premature mRNA, we will then have to add a methyl or G cap to the 5' side of the premature mRNA, and we will then add the poly A tail to the end of the premature mRNA at the 3' side. These two structures will help keep the mRNA, which is a single strand, intact and stay together. So now that we have the premature mRNA with our methyl cap and our poly A tail, there are some mRNA strands inside here which are not used for coding the protein that the DNA wants coded. So this, being spliceosome, will go through and cut at the points where introns are, so here and here. So now that we have cut out the introns, ligase must come in and bond the two nucleotides that are still there. We'll bond them together. We now have our mature mRNA that will then be sent off through the nuclear spores in the nucleus. Now moving on to translation, we have our tRNA, our amino acyl tRNA synthase, and an amino acid, an ATP. So tRNA needs to be charged so that it can be connected to this amino acid. So the amino acid will then come and attach to the amino site, while the tRNA will come and attach to the tRNA site, and using the ATP's energy, they will then be connected and can then be used for the mRNA transcription. Now to begin tRNA transcription, we have our ribosome, the larger subunit and the smaller subunit. They will come together while the mRNA binds at the mRNA binding site, which is about here. So it will then read through the codons on here until it reaches AUG, the start codon, also coding for methionine. So a tRNA with the same anticodon, with an anticodon, which is complementary to the codon being read, will then attach to the P site, which should always start with methionine, and then this will begin the process of elongation. Now that we have initiated the tRNA transcription, after methionine has been coded, the mRNA will move through and be coded for the second codon, which in this case would be LEU. So the anticodon for the codon being read in here will then attach to the A site. You have three sites. You have your exit site, your peptidyl site, and your A site, the EP and A sites. So after the LEU has bonded to the A site, the amino acid from the P site will then attach to the top of the amino acid in the A site, which is the beginning of our peptidyl chain. So then we will then move this tRNA to the exit site and will then be pushed off to the side, while this amino acid will be pushed over to the P site. This then makes it so that another amino acid can be attached to the A site once again, while these two will be moved up to the top. And the process just continues on and on until the peptidal chain has been completed. So now that we have created most of our peptidal chain, once the tRNA reaches the end point, it will then have one of three codons, either UAA, UAG, or UGA. These are all stop codons. So the stop codon will come into the A site, and all the other amino acids will then connect, and this is the end of our peptidal chain. So once the stop codon has been coded, a release factor will come in and break everything apart. The peptidal chain will go off and become its own protein. The tRNA will then go and get recharged by the amino acid tRNA synthase, and mRNA, after the ribosome has broken apart into its two subunits once again, the mRNA will then find another ribosome, which will then code the same protein that can be used for the same function. The end.